So let's take a little bit closer look at general Anova output. So here's what a general Anova output table looks like. Here's the output table using Jamovi for the previous example. So we've got the source of the error in the first column, so treatments, and then error, that's between group error and within group error. Then degrees of freedom here. So for the treatments, k minus 1, so that's the 2. For the within groups, or the error n minus k, that's the 12 here. And then total, if you total these guys up, you get n minus 1. So sample number of observations in the sample, total of all samples, minus 1. And then the next column is sum of squares. So SS is sum of squares. So sum of squares for treatments, sum of squares for error. So that's our 173.33 and 14. And notice here, this is the output for the calculator, TI-84. So notice they've got factor here and error, so factor, treatment. So for factor, we've got degree of freedom 2, sum of squares 173, and then the MS is mean square, so 173.33 right there, our mean square right here, and then degrees of freedom right here. And then for the error, which is the next row, we've got degrees of freedom 12 right there, sum of squares 14, and then mean square 1.16 right there. So the mean square column you just get from dividing the second column by the first column. So this 86.67, that is the 173.333 divided by 2. And then the same thing here. That is the sum of squares divided by degrees of freedom. And then the F statistic is mean square treatment divided by mean square error. So you divide these two entries. So this will be 86.6 divided by 1.16. That's this value here. And then the significance, that column is added on in output. Significance is the p-value. So that's the p-value. And we see that this p-value is very small. That is right here. And it is much smaller than the p-value of 0.05, or the accepted tolerance of 1.05. So that's the general setup for a Anova table. And then notice in each column, if you've got any two of the entries, you can get the last one. They also sometimes will add your degrees of freedom. So if you know one degree of freedom and you know the total sample size n, you can get the other degree of freedom. Or if you know n and k, you can get these other degrees of freedom. So in the homework, I've got a partially completed Anova table like this, and you're filling in the rest of the entries.